Myself, M. Bhanuprasad, working as Assistant Professor in Department of Mechanical Engineering in MVA College of Engineering and Technology. Today, our topic is the alloy steel. Define alloy steel and types of alloy steel. One. So, see here, alloy steel. Alloy steel is any steel other than carbon is called as the alloy steel one. Any steel other than carbon steel is called as the alloy steel one. So generally alloy elements are, what are the alloy elements are, we can see it is one of the chromium one, nickel one, molybdenum one, so vanadium, tungsten, cobalt, boron, copper and others. So these are the alloying elements. So any steel other than carbon steel is called as the alloy steel one. So these are the alloying elements. So this one we can call as the alloy steel one. So classifications of the alloy steel. So generally we have the two types of alloy steel one. The first one is low alloy steel. Second one is high alloy steel, having 3 to 4 percentage alloying elements. So in this low alloy steel one, we can use the alloy elements 3 to 4 percentage only. So that's why we can call as the low alloy steel one. So high alloy steel one. So having more than 5 percentage alloying elements. So not for carbon amma. It is not carbon content. This is the alloy percentage, the alloy elements percentage. So having more than 5 percentage alloying elements, we are using on high alloy steel one. So that's why we can call as it is a high alloy steel one. These are the alloy elements. So these alloy elements we are using in this classification. So low alloy steel, high alloy steel one. 3 to 4 percentage we are using on low alloy steel one. More than 5 percentage we are using on high alloy steel one. So first one is low alloy steel. They have the similar microstructure and require similar to similar heat treatment to that of the plain carbon steel. So it is one of the related microstructure about the low alloy steel one. So they have the similar microstructure and require similar heat treatment. So same similar microstructure and similar we have the heat treatment to the that of the plain carbon steel. That one we can call as the low alloy steel. It is the microstructure. See here is the microstructure of low alloy steel one. So see here classifications of low alloy steel. So again we have the alloy steel. We have the two classifications. The first one is AISI. So second one is HSLA. So the first classification is the AISI means so American Iron and Steel Institute. So American Iron and Steel Institute steels one. So that is the AISI. So what is the HSLA means high strength low alloy steel one. High strength low alloy steel one. So that is the classifications of the low alloy steel one. So see here, so AISA is nothing but American Iron and Steel Institute steel one. So the steels are generally used in mission construction one. So these type of steels are majorly used in mission constructions only. So it is also referred as construction steel and structural steels. It is also referred as construction steels. So construction purpose also you can use the steel one. So it is also referred one or structural steels one. So they have less than about 5 percentage total total they have less than about 5% total addition of elements such as chromium nickel uh, chromium nickel copper manganium molybdenum vanadium extras one. So these are the 5%. They have less than about 5% is total addition of the elements. These are the such as one. So the major interest in this AISI steels groups is hardenability. The major interest in this AISI steels group is a hardenability one. So that is a major definition about the AISI, American Iron and Steel Institute one. So majorly these are used in mission construction one. So it is referred as the construction steel and structural steel one. So that is the main benefit here. So see here another one is HSLA. HSLA, high strength low alloy steel one. This one is a low strength high alloy steel one. It is referred as micro alloyed steel one. So it is referred as micro alloyed steel one. So they have addition of the elements such as aluminum and neodymium and vanadium either slightly or in combination one. So this one we can call as high strength low alloy steel. It is also referred as micro alloy steel one. They have addition of the elements. So additional we are using another elements also. These three types of elements we are using HSLA. So see here in the slide one, high alloy steel. They are different microstructure and require heat treatment. That of the plain carbon steel one. So they compared to other steels one, high alloy steels are different microstructure and require heat treatment. That of the plain carbon steel. So classifications of the high alloy steel are generally classified into two types. The first one is true and die steel one. Second one is stainless steels one. So high alloy steel also generally classified two and die steel, stainless steel one. So we can discuss about first one is first classification, tool and die steels. So see here, tool and die steels. Tool and die steels are extremely important materials. So why? Because they are designed for high strength, toughness, and wear resistance at room and elevated temperature one. So these are extremely important material. Why? Because they are designed for high strength and toughness and wear resistance at the room elevated temperature. So that's why it is one of the very important material. High carbon or high alloy steels are generally used for high carbon and high alloy steels are generally used for tool and die steels one. High carbon and alloy steel. High alloy steels are generally used for tools and dies one. So next one, see here, the most important alloy element in the tools or die steels, including one. The most important alloy element in the tool and die steels include chromium, tungsten, molybdenum, and vanadium. So these are the most alloying elements in tool and die steels one. So see here, two steel and die steel we are separately we are discussing here. Two steels are carbon and alloy steel having a high hardness and strength and wear resistance one. So they are used to make cutting tools. So these are used, these steels are used to make a cutting tools one, measuring instruments and dies. So high speed steels are complex alloy tool sheets which are capable of retaining high hardness and high temperature one. So this one we can call as the tool steel. So these tool steels are carbon and alloy steel, carbon plus alloy steel one, having a high hardness and strength and wear resistance. So that's why they are used for to making cutting tools, so measuring instruments and dies. So and high speed steels are complex alloy tool steels. So which are capable of retaining high hardness at high temperature one. At the high temperature onwards, it retaining the hardness one. So that's why we can call as it is a one of the tool steels one. So next one is die steels one. So cold working dies are made of the steels. So cold working dies, we have the die sum. So in missionaries we can use the dice one. So these total dice are made of the, so these total dice are made of the steels one that are processed. So significant toughness in the addition of their high hardness and wear resistance one. So this is the main one. So cold working dies are made of the steels. Why? Because they possess significant toughness. Toughness is the main one. In this dice, toughness is the more property one. In addition to their hardness one, toughness plus high hardness one and wear resistance one in this dice steels one. So that's why see here small dice are commonly made of the plain carbon steel. Some example one small dice we have. The small dice are made with so plain carbon steel one, but however large and more complex dies are made of alloy steel one. So however large and more complex dies are made of low made of alloy steel one. So that is the main use of the die steels one. So see here hard working dies should retain strength and hardness at elevated temperature. So hard working dice. So we have the cold working this one. So it is a hard working dice. Hard working dice are retain strength and hardness at elevated temperature. At elevated temperature onwards, it retains its strength and hardness in hard working dice one and should withstand fluctuations of thermal stresses due to repeated heating and cooling one. So future these steels should not be susceptible to temperature and brittleness one. So these are the hard working dice one. It is a cold working dice one. So it is the introduction about the tool and die steels one. So tool and die steel one. It is the one of the classification of the high alloy steel one. So see here. So some of the applications of the tool steel and die steels. See here. So this tool steel high speed one. So high speed answer we can use it. We can use it for, see here, M series, T series tools one. So see here, knock resistance one, shock resistance one. So S series one. So hammers. So these are the very hardest material one. So next one is the die steels. Die steel are used to make a hard working dice one, cold working dice one. So cold working dice are these one. So O series, W series, D series, A series one. So comes to here hardworking onwards, so H series, T series one. So these are the applications of the tool steel and die steels one. Tool steel, these are the applications one. These are the die steels applications one. So it is the topic, comma. So next one is, see here. Next one is our topic is stainless steels. Stainless steels. So in addition of the small percentage of chromium one to a plain carbon steel can increase the strength and hardness. So the addition of the small percentage of chromium, so we can use the small percentage addition. So addition of the small percentage chromium to the plain carbon steel can increase strength and hardness one. So in plain carbon steel, some example we can use the chromium one. Automatically what happen means, so increase the strength and hardness and causes a reduction in the critical cooling rate one. So and causes reduction in the critical cooling rate one. So that is the major important for the by using the chromium one. So actually plain carbon steel, your plain carbon steel one, so we can use it for carbon plus alloying elements, but one of the we are using another alloying element is nothing but chromium one. We can use the chromium, we can use it for plain carbon steel one. Automatically what happened, the plain carbon steel means, so it is automatically increase the strength one and hardness one and causes a reduction in the critical cooling rate one. So that is the main definition of the stainless steel one. However, if large amount of chromium is used to the steel one is provided with expectantly good corrosion resistance one. So in large amount of chromium we can use it in the steel one. So it provided with expectationally good corrosion resistance one. So that is the more we can use the chromium one. That is the main benefit for the stainless steel one. Such steels are called as the stainless steel one. So this type of steels one we can call as the stainless steels one. So depending on its structure, stainless steels are generally classified into three groups. So based on the structure one, so these stainless steels are generally classified into three types. The first one is ferritic stainless steel one. Second one is martinez stick stainless steel one. Third one is austenitic Austin Austinic stainless steels one. So these are the stainless steel classifications, and these are the groups of the stainless steels one. So in stainless steel one, what we are doing means we are adding the one of the alloying element. What is the alloying element means? Chromium one. So small percentage of chromium we are adding to the plain carbon steel. After then what happen means, so automatically increasing the strength and hardness one and causes a reduction in the critical cooling rate one, and simultaneously we are increasing the chromium percentage one. After then what happen means steel is providing with the good good corrosion resistance formation one. So such steels we can call as the stainless steels. These are the classifications or groups of the stainless steels one. So next one we can see manganese steels. So it is the chromium one. Chromium are add to the steel one, that is the benefits one. So in steels one we can add the manganese steel. So it is the one of the steel, one of the classification of the steel one. So small amount of manganese we add to the, so small amount of manganese means, see how much manganese we add to the steel means, so 0.25 to 1% is added to the steel one. So after that what happen means, so see here, so 0.25 to 1% is added to the steel one. So deoxide them and combine with the sulfur to reduce its effects one. So small amount of manganese 0.25 it added to the steel one, and so combine with this manganese plus combine with sulfur one to reduce its effects one. So any effects on any steel one, so machine should we can add manganese plus sulfur one of them to reduce its effects one. So some effects means some we can see any steel one, we can see the some environmental effects. Environmental effects means automatically corrosion formation one, cracks, or some other defaults also we can see on steels one. So how can we can reduce this type of environmental effects means by using the manganese or sulfur one to reduce its effects one. So manganese steel with 0.3 to 0.3 to 0.4 percentage carbon and 1.5 to 2.0 manganese have the high strength and used for gear and ties rods and axles. So see here in manganese steels one. So in manganese steels one, so machine should we can add for 0.3 to 0.45 percentage carbon one and 1.5 to 2.0 manganese one. So after that what happen means we can see higher strength. So higher strength we can see on manganese steel one automatically, which purpose by using this manganese steel what we made means we can made for gears and tie rods and axles. By using the stainless steel we can manufacture this type of production one. So gears one, tie rods one and axles one. So see here another manganese steel hard hard field Hadfield manganese steel one. So high manganese steel is called as the Hadfield manganese steel. So high manganese means more manganese we can more manganese percentage we can see on this type of steels one. But actually see here carbon percentage we are using less one. 0.3 to 0.45 only, but see here manganese content we are using 1.5 to 2.0. After then only high strength it become the steel become high strength one. So automatically these high strength manganese steel are used to manufacture gears, tie rods and axles one. So see here and more one we are using compared to 1.2 1.5 to 2.0, more than we can use the manganese one. That one we can call as the Hadfield manganese steel one. So it has the retained last night. So it has retained last night, which works hardness very rapidly and as intentionally high strength due to presence of the manganese and carbon in the solid solution. So in this solid solution, see here in manganese steel one, so mostly we can use it for manganese and carbon one. So in solid solutions, so it contains about 12 to 13 percentage manganese one and 1.2 percentage carbon one. So after then, so by using the how much manganese we are using 12 to 13 one, but in previous one see here in previous one we are using 1.5 to 2.0 only. So after then only we are getting a high strength, but carbon is 0.45 percentage. But comes to here, Hadfield manganese onwards, we are containing 12 to 13% manganese one and 1.2 percentage carbon one. After then what happened? It is extremely tough and wear resistance and non-magnetic one. సో మనం ఎప్పుడైతే మ్యాంగనీస్ కంటెంట్ 12 to 13% యూజ్ చేసి కార్బన్ కంటెంట్ 1.2% మిక్స్ చేసామో అప్పుడు extremely it is a one of the toughest material and we can observe on wear resistance and non-magnetic we can see on this type of steels one hard field manganese steels అమ్మ. సో హార్డ్ ఫీల్డ్ మ్యాంగనీస్ స్టీల్స్ ఎందుకన్నాం అంటే మ్యాంగనీస్ కంటెంట్ ఎక్కువ యూజ్ చేస్తున్నాం, కార్బన్ కంటెంట్ తక్కువ యూజ్ చేస్తున్నాం. సో దట్స్ వై వీ కెన్ కాల్ యాజ్ హార్డ్ ఫీల్డ్ మ్యాంగనీస్ ఫీల్డ్. సో ఇలా యూజ్ చేయడం వల్ల మ్యాంగనీస్ ఎక్కువ యూజ్ చేయడం వల్ల ఏమవుతుందంటే స్టీల్ లో సో టఫ్నెస్ ఇంక్రీజ్ అవుతుంది. సో నెక్స్ట్ వన్ ఇస్ వేర్ రెసిస్టెన్స్ ఇంక్రీజ్ అవుతుంది. సో ఇట్ బికమ్ యాజ్ ఏ నాన్ మ్యాగ్నెటిక్ గా. సో ఈ స్టీల్స్ ఏమవుతుందంటే నాన్ మ్యాగ్నెటిక్ గా బిహేవియర్ అవుతుంది. So the steels is widely used in the minings. So where we can use this type of steels means these steels used in minings. So excavator buckets, so excavator buckets. So in minings we can use this type of buckets. One excavator buckets is manufactured by using the hard field manganese steel one. So railways one, railway track work one, railway track work also you can use it for hard field manganese steel one, and jaw crushing machinery, so stone crusher jaws one, so extras one. So these are the applications of the hard field magnet steels one. So high magnet steels are hard field magnet steel is available as castings. So this type of steels also available in castings. So forging or hard rolling sections also. So in this manufacturing production also we can use it for high manganese steels, which manufacturing industries means casting. In casting also we can use it for high manganese steel, and forging and hard rolling section also. Forging is nothing but it is one of the heat treatment process అమ్మ కొలిమి అంటే నథింగ్ బట్ ఇప్పుడు మనం కొడవళ్ళు గొడ్డలు చేస్తారు కమ్మా రోడ్ సైడ్ ఏం చేస్తారు కోల్ వేసేసి బాగా హీట్ చేసేసి మెటీరియల్ ని దాన్ని బాగా ఫోర్స్ అప్లై చేసి మనకు కావాల్సిన డిజైర్ షేప్ లో కన్వర్ట్ చేసుకుంటూ ఉంటారు అనమాట. దట్ వన్ వీ కెన్ కాల్ ఇస్ వన్ ఆఫ్ ది ఫోర్జింగ్ ఆపరేషన్స్ అమ్మా. నెక్స్ట్ వన్ ఈజ్ హార్డ్ రోలింగ్ సెక్షన్స్. హార్డ్ రోలింగ్ సెక్షన్స్ అంటే వీ కెన్ సీ ది టూ రోలర్స్. ఏదైనా సరే ఒక రెండు రోలర్స్ తీసుకొని రెండు రోలర్స్ మధ్యలో మనం ఈ మ్యాగ్నెస్ స్టీల్ అనేది ఉంచేసామంటే ఆ స్టీల్ ఆ రోలర్స్ ఏం చేస్తాయంటే కంప్రెషన్ చేస్తాయి దేన్ని మ్యాగ్నెస్ స్టీల్. అప్పుడు ఏమవుతుందంటే అవి హై టఫ్నెస్ గా మారిపోతాయి, వేర్ రెసిస్టెన్స్ కన్వర్ట్ అయిపోతే బికమ్ ఇట్ ఈస్ నాన్ మ్యాగ్నెటిక్ అనమాట. సో దిస్ టైప్ ఆఫ్ ఇండస్ట్రీస్ వీ కెన్ యూజ్ ఇట్ ఫర్ హార్డ్ ఫిల్ మ్యాగ్నెస్ స్టీల్స్ అనమాట. సో బట్ ఇట్ ఈస్ ఏ డిఫికల్ట్ టు మిషన్. సో it is a very difficult to machine as it tends to hardness when machining is attempted. So these are the hard filled magnet steels. Some applications of magnet steels as given in the table. See here is the application of the magnet steels. One is here. So see here, so carbon content we can use it for 0.2. So manganese we can use it for 1 to 1.3 to 1.71. So applications means see here automobile axles, crankshaft, connecting rods we can manufacture them. So this is the carbon content, this is the manganese content. By using these two material we can manufacture this type of spare parts. One, what are the spare parts means automobile axles, so crankshafts and connecting rods. So by using the carbon content 0.35 and manganese we can use it for 1.3 to 1.71. So often what are the parts we can manufacture means axles, gun parts, levers, spindles we can manufacture. So increase the carbon content 1.01. To increase the manganese also 2.0. Often what are the parts we can manufacture means see here plug gauges, blanking dies, press tools and cams one. So again we are increasing the carbon content. How much means 1.2, here 1.0 only we are using one. So we are increasing maximum is 1.21. So here manganese also we are increasing, maximum is 13 percentage one. After then we can manufacture by using this material manganese steel material one we can manufacture jaw crushing machinery, dredging equipments. So next one is railway tracks works and power soil streets one. So by using this type of metal we can manufacture this type of spare parts one. So it is the minimum manganese carbon content is we can use it for 1.3, maximum we can use it for 13 percentage. The carbon content in manganese steel we can use it 0.2, the maximum is 1.2 percentage. By using these material one we can manufacture this type of spare parts. This is the topic one for the manganese steel. So what is the manganese steel and application of the manganese steel, and we can increase the manganese one, that manganese steel we can call as the hard filled manganese steel. So in manganese steel generally we are used for manganese 0.25 to 1% only, but after then we can use it more than 1% we can use it for manganese steel. That one we can call as the hard filled manganese steel one. So the highest manganese content we can use it for 12 to 13 percentage one. The carbon content we can use it 1.2 percentage. After then we can manufacture this type of spots one. This is the total introduction and applications of the manganese steel. So see here it is the alloying elements. So our topic is alloying elements. So elements and its effects. By using these are the elements. So by what is the effect of these elements? So some example one, aluminum is one of the element. So what is the effect of the aluminum? By using the aluminum element in the material, so what is happening means, see here by using the aluminum automatically we can get a strong deoxidizer formation one. So and refined grains we can get on aluminum one. So chromium we can use the chromium one. So these are the effects. Ferrite stabilizer, rises tensile strength, effective strength, hardness and wear resistance we can see on particular material one. So this type of elements we can use it for steel one. So these are the effects we can see. So effects అంటే ఏంటమ్మా ఇవన్నీ అల్లాయ్ ఎలిమెంట్స్. ఈ అల్లాయ్ ఎలిమెంట్స్ కనుక మన స్టీల్ లో యూజ్ చేస్తే ఆటోమేటిక్ ఏమవుతుందంటే ఆ స్టీల్ యొక్క ప్రాపర్టీస్ చేంజ్ అవుతా ఉంటాయి. ప్రాపర్టీస్ ఎలా చేంజ్ అవుతాయి అంటే ఇలా చేంజ్ అవుతా ఉంది. అల్యూమినియం యూజ్ చేస్తే ఇలా అవుతుంది. ఏమవుతుందంటే అల్యూమినియం యూజ్ చేసుకుంటే మనం ఎఫెక్ట్ అబ్జర్వ్ చేయొచ్చు అంటే మెటీరియల్ స్ట్రాంగ్ డీఆక్సిడేషన్ ఫామ్ అనేది మనం అబ్జర్వ్ చేయొచ్చు. రిఫైన్ గ్రెయిన్స్ అనేది అబ్జర్వ్ చేయొచ్చు. క్రోమియం కనుక యూజ్ చేసినట్టయితే వీ కెన్ సీ దిస్ టైప్ ఆఫ్ ఎఫెక్ట్స్. So see on the alloy steels one. So ferrite stabilizer rises tensile strength one, effective strength, hardness, and wear resistance one. So next one is we can use it for cobalt. So cobalt we can use it cobalt one. After them we can see cobalt effect of the discernment. So prevent grain growth, retain hardness and strength, and high temperature also improves the thermal conductivity by using the element copper one. So effect of the copper is nothing but rises the yield point one. So manganese, this is a manganese element one. This is the effect of the element one. So carbide stabilizer one improve strength one, hardness, hardenability, and eliminates evil effects of the sulfur one. So molybdenum we can use for molybdenum. We can this is the effect of the element one. So enhance resistance to creep and maximize the temperature one. Also increase the resistance to corrosion one, corrosion of the high chromium steels one. So by using the molybdenum, so this is the effect of the element. So nickel, it is the nickel one. So by using the nickel one, what are the effect we can see on the metal means, see here it is the effect one. So increase of the basic strength one, and stabilizer acts as graphizer one. See the effect one. See here another one, silicon. You can use it for silicon one. So that is the effect of the silicon one. Stabilizer and hardness. Fermate one improves the resistance to corrosion one. So titanium we can use it for titanium. Forms of the, it is the effect of the titanium. So forms of hard and stable carbides. So stabilizers stainless steels and rises strength one. So next one is wolfram for wolframite. We can use it for wolframite element. So what are the effect of the wolframite element means? So stabilizer carbides improve the strength and hardness, and also enhance cutting power of the tool one. So vanadium we can use element one. So what are the effect of the vanadium element means? Refined grains and stabilizer ferrites. Most of the same effects as wolframite. So next one is boron. It is one of the boron element. By using the boron element, what are the effects we can see on boron elements means? Improves hardenability of steel, remarkability. So these are the elements and effects of these elements. So these are the elements. So what are these type of elements we can use it for alloy steels one? So by using these type of elements, we can see some effects we can see on the particular steel one. So these are the effects one. So see here another effect of alloying elements. So the most economical way of increasing the hardenability of the plain carbon steel is to increase the manganese content one. So most economically increase the hardenability of the plain carbon steel one automatically to increase the manganese content from 0.60 weight to 1.40 weight gives a so sustained improvement in hardenability. So in plain some example one, so in plain carbon steel one we can use it this content of the manganese, automatically we can see improvement in the hardenability one. So see here next one is chromium and molybdenum, also very effective and among the cheaper alloying additions for the unit of the increasing hardenability. So మన plain carbon steel లో we can increase the hardness one automatically to use this type of alloying elements. So what are the alloying elements means? Manganese we can use automatically this percentage of manganese you can use it for steels one, alloying a steels one to improve the hardenability. Chromium and molybdenum also very effective elements. So we can use it, it is also very cheaper one alloying elements also. We can add this one to the alloy steels one to increase the hardenability also. So boron has a particularly large effects. So when it's added to the full dioxides, low carbon steels one, even in the concentration of the order of the 0.001 percentage would be more widely used in the distribution, and steels could be more easily controlled one. So boron has particularly large effects. So by using the boron in low alloy steels one, we can see large effect one. So see here boron effect means, so see here it is a boron effect. By using the boron in the alloy steels one, we can see that these effects one. What are the effect means? Improves the hardenability of the steel so remarkably. So these are the effects of the alloy elements, Amma. So it is a today topic, Amma. Thank you, Amma. So once again, I repeat the class one. See here. So Today our topic is alloy steel one. Alloy steel. So it is the alloy steel. So any steel other than carbon is called as the alloy steel. Amma. So in the alloy steel one, we can use it this type of alloying elements: chromium, nickel, molybdenum, vanadium, tungsten, cobalt, boron, copper, and other elements you can use it for alloy steel one. So మన alloy steel లో ఈ elements use చేసుకుంటే we can see there some improvement of the ప్రాపర్టీస్ వన్. సో ఈ ఎలిమెంట్స్ కనుక మనం alloy steel లో యూజ్ చేసుకున్నట్టయితే మన ఇంప్రూవ్మెంట్ చూడొచ్చు ప్రాపర్టీస్ లో. Of then the material becoming stronger, tougher, machinability, hardenability, corrosion resistance one. This type of properties we can observe on alloy steel one by using these alloying elements one. So see here classifications of the alloy steels one. So they are basically there are two types one. First one is low alloy steel one. So next one is high alloy steel one, having 3 to 4% is alloying elements. So alloying elements we can use it for low alloy steel 3 to 4%, but when it comes to high alloy steel one we can use it more than 5% one. So next one is low alloy steel. It is a basic introduction about the low alloy steel. It is a microstructure one. So it is a microstructure one. Next one is we can see classifications of low alloy steel one. Generally low alloy steel generally classified in two types. One is AISI, American Iron Steel Institute. Steel Institute one. Next one is HSLA, high strength low alloy steel one. So it is the first classifications of the low alloy steel one, AISA introduction one. So these are the elements we can use it for AISA. So is the ASY. Next one is HSLA, high strength low alloy steels one. High strength low alloy steels. This is a microstructure and additional elements we can use it for high alloy steels one. This one. So next one is we can see high alloy steels. What is a high alloy steels? Also again classified into two types. This is a low alloy steel one. These are the classifications of the low alloy steel one. So it is the high alloy steel classifications, second one. So they have a different microstructure and required heat treatment that of the plain carbon steel one. This is the classifications of the high alloy steel one, tool and die steel and stainless steel. Tool and die steel and stainless steel. So it is a tool steel and die steel introduction one. So these are the applications one. So next one is the stainless steel one. Next one you can see these are classifications of the high steel, high alloy steel one. So comes to here, it is a new topic. New topic is nothing but manganese steel and hard field of the manganese steel is one. So next one is effect of the elements. So alloy steels. So we are using this type of elements for the alloy steels one. So these are the effects of these alloying elements one. So it is the alloying effect of the alloying elements one. Thank you, Amma. This is a today class one.